Okay, good afternoon, students. So last time, basically, let us quickly revise the contents that we have discussed in the earlier classes. Okay, so the topics that we covered in the last class were basically starting off with the definition regarding the population. Okay, so we define what is the meaning of population. Okay, it is derived from a Latin word populatio. Okay, that means basically people. Okay, so a group of people residing in any particular area is known as population. Okay, now moving on to the further part. Okay, that is population. Okay, so population, whenever we have exceeding number of people living in any particular area. Okay, suppose we have, let's say, 10,000 people living into 1 square meter of area, that is called basically a density. Okay, so now density and overpopulation are slightly different terms. Okay, overpopulation means basically wherever the number of people are more than carrying capacity. Okay, I defined the word carrying capacity in the last lecture. Okay, so all of you must be very much aware regarding the carrying capacity. In a normal or a simple language, if I want to explain you what is the meaning of the term called carrying capacity, it means that basically how many people out of the given population are getting all the basic requirements of the life, all the basic amenities that are needed for the life. Okay, so those part is limited. So if your population is exceeding the carrying capacity, that means it is a overpopulation. Okay, that is a problem to the society. Okay, so first of all we studied the causes of overpopulation, that what are the different causes. Okay, so in chronological order we started off with the high birth rate. So high birth rate is one of the biggest, you can say, the reasons for the overpopulation. Same way, low death rate. Low death rate because nowadays medical science has expanded, it has advanced, and we have the capacity to fight against deadly diseases. Okay, so due to that, it is very much important that the overpopulation does not happen, because high birth rate and low death rate are directly resulting into the net positive value. Okay, same way the third factor was migration. People move around in the city area, or people move from one rural area to the urban area in search of a good quality of life, good quality of the job, or the basic amenities. Okay, nowadays very less people intend to live in the rural area. Why? Because the facilities that are there in the urban areas are not available in the rural cities. Okay, so that is one of the primary concerns. Okay, and the last one we discussed was illiteracy. So illiteracy is again one of the biggest reasons. Illiteracy and poverty are directly related. Okay, and that is one of the biggest reasons for high, or you can say the big families. Okay, so that is all the different causes. Thereafter we saw the different effects of the overpopulation. What are its effects on the economy, what are its effects on the society. Okay, so that was our agenda of the last session or last lecture. Today we are going to start off with the population growth rate. Okay, so first of all we will define the term, then we'll see there are two types of the growth rate, logistic and exponential. So we'll study them in the detail, and then we shall cover the numericals. Okay, there are some of the numericals in this particular module, so we shall cover that also. Okay, and in the next session we are going to start off with the population growth theories. Okay, so for today's session you will require your calculator, book, and a pen. Okay, so arrange that in a minute. Okay, then we shall start with this, because after the initial discussion of 10 to 15 slides, okay, there will be the calculative part. Okay, so I think you should copy it down along with whatever we are doing, so that it will be easy for you during the exam also. Okay, so please just arrange the book, pen, and a calculator. Okay, I'll start in a minute. Okay, there are few students who are asking for the marks of the test. So the marks of the test you will be getting on your email, okay, by today or by tomorrow. So you can look into that. Okay. Okay, so our first point of discussion for today is population growth rate. Okay, so the population growth rate can be expressed by a certain formula. Okay, so population growth rate is a fractional rate at which the number of individuals in a population increase. Okay, so here the particular formula is given to you. So what it suggests that the population at the end of the period minus the population at the beginning of the period divided by population at the beginning of the period. So let us consider this with the help of one example. Okay, so suppose end of the period means, let's say we have counted the population of Rajkot city in 2021, that is current year. Okay, and it is coming out to be 12 lakh people. Okay, 12 lakh people. This is just an example. Okay, minus population at the beginning of the period. Now we need to decide that how much period we need to observe. Generally the census which is being counted, it is counted at the every 10 years. So suppose in 2011 there was a last calculation, and at that time the population was around 9 lakh people. Okay, so according to this formula, what does it suggest? It suggests that 12 lakh minus 9 lakh should be the numerator value. So how much it is? It is 3 lakh. What is this 3 lakh? 3 lakh is basically nothing but the increase in population during that particular period divided by population at the beginning of the period. So what was that? That was 9 lakh. Okay, so I can say that the value is coming out to be 0.33. Okay, so I cannot say that this is the growth rate. I need to multiply it by 100. Okay, so when I multiply it by 100, I am getting 33.33. Okay, so 33.33 percentage is the population growth rate for that particular period, which is tremendously very high. Okay, this much population growth rate generally does not happen. Okay, but if you just consider the example, because since the Rajkot city is becoming the hub. Okay, so before 10 years whatever the population was there, that was accounting only for the Rajkot city, but now due to the different facilities, people from the nearby areas are also increasingly coming onto the city and they are residing into the city. So it is possible that it is having a growth rate of around 30%, which is a very huge figure. So now you imagine that earlier whatever the carrying capacity, what is the carrying capacity? Carrying capacity means whatever the items or the things that were needed for the survival, that are the basic amenities that were fixed. Okay, so that are increased now, but it is not increased by 30-40%. So now you can say that there is a comparatively overpopulation as compared to the last decade in our city. Okay, because resources have increased, but it has not increased up to the level of the population. Okay, so that is why some of the people still don't get the basic necessities, still don't get the basic resources for the life. Okay, and as a result of which what happens? Poverty and the unemployment increases. Okay, so this is regarding the population growth rate. So any doubt, then just tell me. Okay, next is okay, next is exponential growth rate. Okay, so now we need to study this particular term as well. Okay, so in this, the rate of change of population is directly proportional to the population at that time. Okay, so if after time t, okay, I don't know how much is t, I have to keep it or I have to assume it according to my convenience. Okay, so if after time t population is nt, okay, nt, and r is the population growth rate. Okay, r is the population growth rate, then differentiation, that is dnt by dt is equal to r into nt. Okay, dnt by dt, okay, everyone has done this differentiation in your mathematics classes. Okay, so according to the formula, it is equal to r, that is the population growth rate, into nt. Nt is the population at the time period t. Okay, so when you remove this and when you solve it, the equation becomes nt is equal to n naught. N naught is the initial population. Okay, e, that is the natural log raised to r into t. Okay, what is r? R is the growth rate of the population, t is the time period. Okay, so the above mentioned equation is used for calculating the exponential growth rate. Okay, so this equation we are going to use in the numericals, so just have a quick note of this. Okay, just quickly note this down. Okay, then I shall move to the next part. Okay, so I hope this is over. Okay, so the next part is doubling time. Okay, so now suppose if I want to know that in how much time period will the population of any particular area will get doubled. Okay, so the time required for a population to double itself is called the doubling time. Okay, so in this, when nt is equal to 2 times n naught. Okay, so in the earlier equation, what is this nt is the final population or population at a time t. So what I require the population to get doubled. So earlier one was n naught. So if I want to do double of that, I have to multiply it by 2. So when nt is equal to 2 times n naught, t is equal to td. Okay, that is the doubling time. Okay, then equation becomes, the earlier equation itself becomes td is equal to 0.693 divided by r. Okay, so this equation is also important for short questions, for long questions of 3 or 4 marks, and for the mcq question. So please note this also. Okay, so td is the doubling time is equal to 0.693 divided by r. So if I just know the value of r, I can say the doubling time of the population. Okay, in between, if there is any doubt, just please mention. Okay. Okay, next, logistic growth rate. Okay, so rate of increase of population never remains constant, but it will vary with time. Okay, I will show you this particular example with the help of the graphical curve. Okay, it is also known as S-shaped, or it is known as a sigmoidal growth curve. Okay, so remember these points. Okay, so this curve, that is a logistic growth rate curve, is density dependent. Okay, this question generally comes for the MCQs or the short questions. Okay, this curve is density dependent, that is dn by dt is equal to r into n into the bracket 1 minus n by k, where n is equal to the population, k is called the carrying capacity, and r is called the logistic growth rate. Okay, so remember this thing and also note down this. Okay, so these are the last points. We are moving on to the numericals in 1 or 2 slides. Okay, but before that I will just show you this particular graph. Okay, so dn by dt is equal to 1 minus r into n into the bracket 1 minus n upon k. N is the population size, k is the carrying capacity, and r is the growth rate. Okay, so the factor 1 minus n by k is called as an environmental resistance, and it becomes negative when the population exceeds the carrying capacity, and thus the factor 1 minus n by k is responsible for achieving the logistic growth from the exponential growth. Okay, now this logistic growth, it is divided into the 3 phases. Now what are those 3 phases? Phase 1, in which population size is much less than the carrying capacity and rate of growth is proportional to the population size. So here the carrying capacity is more and the population size is less. So that is a good suggestion, or you can say a good criteria. Okay, in the second phase, increase in population is rapid compared to the phase 1, but the growth is steady. So that is why dn by dt is constant value. And in the phase 3, the population growth decreases as population approaches to the carrying capacity, that is dn by dt is equal to 0. Okay, these 3 phases will be much more clear in this particular graph. You can see over here that initial process is slow, but the acceleration in the middle part is fast, and it rate slows down when it approaches the carrying capacity line. You can see this, and in the exponential growth rate, it increases directly proportional to with the time. Okay, so this is the logistic growth rate, and this is the exponential growth rate. So you can see that both these are having a different figures, different approaches. Okay, the exponential curve, also known as J curve. Okay, the other one was known as a sigmoidal curve. Okay, it occurs when there is no limit, no population size. Okay, the logistic curve is known as S curve or sigmoidal curve. It shows the effect of limiting factor. Okay, so in this particular case, that is the carrying capacity of the environment. Okay, so you can see over here again the carrying capacity. Okay, that is basically the theoretical maximum population. See, carrying capacity is just a imaginary term, or you can say just a theoretical term. Okay, you cannot have fixed this much amount. Okay, but theoretically it exists. Okay, that if your population size is breaching that particular mark, that is the carrying capacity line, then you are in trouble as an environment or as a society. Okay, so this population is growing rapidly in this particular phase. Okay, but when it reaches or when it is nearby the carrying capacity line, the growth will be slowing down. Okay, and the growth stops, and the population stabilizes at the carrying capacity K. Okay, so it is just in line with the carrying capacity K over here in this particular phase. Okay, so this is regarding the different growth rate, population growth rate, okay, logistic and the exponential growth rate. Okay, so if there is any doubt, you can just tell me very quickly. Okay, otherwise we shall quickly move on to the next part, that is the numericals regarding the growth rates. Okay, so okay, so here first of all, before solving the numericals, it is very important that you have a fair idea regarding the formulas that we are going to use. Okay, so the formula that we are going to use over here, okay, you need to just first of all recall this a particular equation, that is population at the end of the period minus population at the beginning. I gave you an example, 12 lakh minus 9 lakh, that is 3 lakh divided by 9 lakh. Okay, and into 100 when I say, that will give me the percentage value. Okay, so this growth rate is clear. Okay, then exponential growth rate is nt n naught e raised to r into t. Okay, so nt and n naught, I think you know that will be a general figure. R will be the growth rate and t will be the time period, or you can say the time frame that is decided upon. Okay, so doubling time, that is td, is equal to 0.693 divided by r. Okay, so 0.693 divided by r. Okay, where this 693 came from, if you do the natural log of 2, it will give you this value. Okay, so it is coming from there. Okay, and logistic growth rate, which is a density dependent, dn by dt is equal to gamma into n 1 minus n by k. Okay, so just remember all this and let us move on to the first question. Okay, see the solutions and the questions both I have mentioned it together. Okay, so first of all write down the question on the screen and then just see the solution. I'll help you out with the solution first of all. Okay, but please note down all the questions. Okay, because when you read you will not have the questions if you are not noting it down. Okay, so first is very basic question I have put forward. So as of 1995, okay, is the screen visible for everyone? Okay, so any doubt in the calculations, just quickly tell me. I'll give you an option, I'll give you a chance to unmute also if there is any serious question regarding any of the points. Okay, so don't hesitate. Okay, so as of 1995, human population was expected to double within 50 years. Okay, calculate R from the human population. So now see, first of all, whenever you see this type of the question where there is a doubling in the population, you have to use the same equation that we have derived. That is T double or TD is equal to 0.693 divided by R. Okay, so here it is very simple. Since I know the equation, I have written down T double is equal to 0.693 by R.
Okay, so r over here I need to find out. Okay, so t double, that is it will double within how many years? It will double within 50 years. So 50 over here, 0.693 divided by r. Okay, so when I isolate this r on one side, what I have to do is I have to do the calculation of the remaining terms. Okay, that is 0.693 divided by 50. It will give me 0.0138. Okay, so this is the value that is for r. Okay, if I am representing in terms of the point, it is okay. But if I want to mention it in the case of the percentage, then I have to multiply it by 100 and introduce a sign of the percentage over here. Okay, so quickly note down. Okay, next one is slightly different. Okay, so if human population in 1993 was 5.4 million. Okay, if human population in 1993 was 5.4 million. Okay, now you just see that this is the first value of the population that is given to us. Okay, so I will put n naught. Okay, so what was the projected population size in the year 2000? Okay, so R is equal to 0.0138, that is given to us. Okay, time period will be equal to 2000 minus 1993. Okay, so T is also given to me. Okay, so I need to just find out the value of NT because I require the population, projected population size in the year 2000. Okay, so 2000 is the year. Okay, so NT will be population at the year 2000. Okay, so which formula should I use? I will use the second formula that I have. Okay, so this is equal to NT. Okay, NT is equal to N naught E raised to RT. Okay, now what is this E? E is equal to the value that you will get by pressing the shift and natural log on the calculator. Okay, so N naught value is 5.4 million because that is the initial value. E you keep it as it is, R value you substitute, and T value you substitute, that is 7 years. So first of all solve this both. Okay, so 0.0138 into 7, that is giving you 0.0966. Okay, now press shift and press the natural log, you will get E. Okay, and then take the value of E, 0.0966. Okay, so you will get around 1.101419. Okay, everybody I think is getting this value 1.1014. Okay, multiply it with 5.4 million. Okay, and you will get the value. Okay, so just see this. Everybody is getting this answer or not? Please confirm. Please use your calculator and confirm if you are getting this answer or not.
Okay, even though you have done the calculation on your own, please copy down these values, because at the time of examination, if you don't have this type of the notes, then you will easily forget the formula. Okay, so please copy down, and then we will move on to the next question. Okay, so I suppose many of you are getting the correct answer. Okay, next question. Okay, population in a city increases by 12% every year. Calculate the doubling time of the population. Okay, now this is also a question of T double, but it is drafted in a different manner. Okay, so you should understand that what is being asked. Okay, population increases by 12% means it is nothing but it is given the growth rate to you. Okay, so growth rate is 12%. So I don't want percentage. So if I want to remove the percent sign, I have to divide it by 100. So 12 divided by 100 is 0.12. Okay, so T double is equal to 0.693 divided by R is 0.12. Okay, so 0.693 divided by 0.12. Okay, yes, very good. So this is the correct answer, 5.77 years. Okay, so TD, or you can say T double, is equal to 5.77 years. Okay, so please note down very quickly. This is very simple, but you should get to know that what is particularly asked to you. Okay, moving further. Okay, so according to estimate, population size of insect is 3000. According to estimate, population size of insect is 3000 over the course of the month. Okay, so in duration of 1 month, we record 400 birth and 150 death in the population of the insect. Okay, population of the insect is changing by 400 birth and 150 death. Okay, estimate R, that is rate of growth, and calculate the population size predicted to be in the 6 month period. Okay, so in 6 months, what is the population that you have to predict? Okay, so first of all, 3000 was the initial value that was given to us, so I will put it as n0, or you can say n0. Okay, so in this 1 month period, 400 births are happening, but 400 is the value on what? 400 is the value on 3000. Okay, 400 is the value on 3000, so 400 divided by 3000 will give you 0.133, which is the birth rate. Okay, and death rate is 150 divided by 3000, it is the death rate. Okay, so birth rate minus death rate will give you the R value. Okay, instead of this, if you don't want to do this entire thing, you can also do this 400 minus 150, because birth rate minus death rate will give you the net value.
Okay, so this will become 400 minus 150, that is 250. 250 divided by 3000 will directly give you this 0.083. Okay, so either way you do it, both are the correct options. Okay, so now you have the value of r, you have the value of n naught. Okay, so substitute in this equation. So n naught is 3000, e raised to r was 0.083, okay, and t, that is 6. Okay, because it is given over here as 6 months, that is why I have to put 6. Okay, so 3000 e raised to 0.083 into 6. So first of all multiply this, then take the log. Okay, so you will get this 1.645. Okay, and 3000 into 1.645 is 4936 insects. Okay, so I think it is clear. So quickly just write this down. Okay, so I think now you are very comfortable with this type of a question. So a slightly different question. Okay, so a sample of algae, or you can say insects from the site, provides an estimate of 1 lakh cells on initial sampling date. Okay, so now see, this is the initial value, initial sampling. Okay, so n naught is 1 lakh. 10 days later, the population size was estimated to be 5 lakh cells. So it is 5 lakh and t is 10 days. Okay, now see, important point is, whenever you are using this formula, don't do any type of the conversion. Suppose this is given in days, you use it in days. So whatever the answer that you will get, that will be per day. Suppose it is given in months, you put whatever the value is given, that answer will be per month. Okay, and suppose it is given in year, then it will be the yearly value. Okay, so don't do any type of the conversion of the day, month, and year. Okay, that is not to be done. Okay, now nt is equal to n naught e raised to rt. So technically, what happens, that I have written over here. Okay, so 5 lakh. Okay, so log of 5 lakh minus 1 lakh is equal to r into t. Okay, so this is how we are getting the final value of r. Okay, 13.12 minus c. Here I am removing this e. So when I remove this e, the natural log will be introduced on both the sides. Okay, that is why you have to take this ln 5 lakh ln 1 lakh. Okay, so R value will be equal to 0.616. Okay, so just note this down first of all. Okay, next part is, for the same question, predict the population after another 10 days. Okay, now you see that earlier we were at point 0. Okay, at that time the population was 1 lakh. At day 10 the population was 5 lakh. Now they are telling that again you do the same thing after 10 days. So from the initial value it is asking for 20 days. Okay, but since I want to put this as 10 days, my initial value now becomes how much? 5 lakh, because I'm standing at day 10. At day 10, n naught is 5 lakh. Okay, and after 10 days I want the reading. Okay, so nt, which is unknown value, is equal to 5 lakh e raised to r. R will remain same because the growth rate, or you can say the growth pattern, will be same. Okay, so 0.16 into 10 more days. Okay, so multiply, you are getting this 2476516.21. Okay, just note down. So this is the extra item that is given in this question. Okay, next is, a population of butterflies exhibit the logistic growth pattern if the carrying capacity, okay, so this is K value, is 500 butterflies and rate R is equal to 0.1 individuals. What is the maximum population growth rate of the population? Okay, so maximum population growth rate will occur when n is equal to K by 2. Okay, so using the equation, K is given as 500, R is equal to 0.1. Maximum population will occur, growth rate will occur when n is equal to K by 2. K is 500, so this will be equal to 250. So dn by dt, which we need to find out, is equal to R into n. So R is the growth rate, that is 0.1. N value is this much, that is K divided by 2. Okay, and 1 minus 250 by 500. Okay, so dn by dt is coming out to be 12.5 individuals per month. Okay, so this type of a question is rare question, but since we have introduced a formula, I have added one of the questions for your reference. Okay, clear? So next question is from the population growth rate theories. Okay, so the next question I'm not going to do it right now because the concept is still not covered. In the next session, when it will be covered, I will just help you out with this numerical also. Okay, so we'll stop up to this point of the logistic growth rate. Okay.
Okay, so any doubt in any of the numerical, then please quickly comment. Okay. Otherwise, just stay online for 2 minutes. I will take your attendance. Okay. Okay. The remaining part that we are going to discuss next time, that is regarding the population growth theories. Okay. Okay, so the questions regarding the doubling time of the population, the question regarding the growth rate, calculation of R, calculation of total population after n number of years. Okay, all these are clear for everyone. Anyone has any doubt in any particular question, because we solved two or three different type of the question. Okay, next time, in the next session, we shall finish the theoretical part in this module itself. Okay, so if there is any question till then, please quickly tell me. Okay, so that I can look forward to it. Okay, anyone, any questions? Okay, so I have noted down your attendance. Okay, and the test mark you will get it on your email. Okay, so I noted down your attendance, so if you want to leave, you can leave. So we finish over here. Okay, so thank you very much, have a nice day. Okay, have a nice week. We shall meet again in the next week.